We are not learning any new transformations today. We're just going to put all the transformations together in what's called vertex form. Now, before today, the only technical form of a quadratic that you have learned about is y equals ax squared plus bx plus c. That's called standard form. Now, that's the form that looks like the things we factor. It's the ones that we've graphed in Desmos and found all the important points to graph. But today, we're going to use what's called vertex form of a parabola. Now this right here is vertex form. It's found on your formula chart, and it's definitely a formula that is super helpful when it comes to quadratics. It's called vertex form because there are numbers in here that will actually just straight up tell you the vertex, and you don't have to graph it, you'll know where it is. But what else is cool about vertex form is that it actually lays out all of the transformations you've done to this graph and allows you to quickly see what transformations we have applied. If you think back to the things we've learned so far, if we have an A that is greater than 1, that means it's a Dolly Parton number, then you know that this is going to be a vertical stretch. That means it's going to get narrower. So you're going to have a narrow parabola. But if that number A is a JLo number, so it's bigger than 0 but less than 1, that's going to be called a vertical shrink. And that vertical shrink is going to make your graph super wide. So the A value in vertex form is going to tell you if it's a stretch or a shrink. But also, if that number is negative, if there's a negative sign in the very front of that equation, then you know that you have a sad parabola. That's called a reflection in the x-axis. So this is your sad parabolas. Sad parabola. Opening down. So already right there, just by looking at one number that we're going to plug into vertex form, we already know whether it's a stretch or a shrink, and if it's flipped over, meaning it's a reflection in the x-axis. What's also really cool is that within vertex form, we also know both of our translations. The number inside the parentheses is h, and h is going to tell us how much it moves side to side. Now, since there's already a minus sign in the formula, that means we're going to go the opposite directions because horizontals are inside and opposite. Hi-oh. So if you have a minus sign, okay, like right there, if you have a minus sign in your formula, that means we've plugged in a positive number. So that's going to move to the right. So minus sign is to the right. But if you have a positive number in there, that means you've plugged in negative because negative times a negative is a positive. So that means the negative signs in my parentheses, the ones that I see, the positive signs in those parentheses are actually going to translate this graph to the left, the opposite of the direction that you think. And then at the very end, you have K, and K is going to tell us our vertical translations. If you have a plus K, it's going to go up. If you have a minus K, it's going to go down. So again, that's on the outside, which means it's a vertical translation, as opposed to the H being on the inside of the parentheses, making it a horizontal translation. Now, like I said earlier, vertex form isn't just helpful because it tells you the transformations. It also straight up tells you the vertex and the axis of symmetry. The number that you have listed for H, the one that you've plugged in, so the opposite of what you see, is the x-coordinate of your vertex. And the k that you see is the y-coordinate of your vertex. If you remember back a couple videos, a couple lessons ago, we labeled the vertex as H and K, and I told you don't worry about that yet. This is why we labeled them H and K, because they come exactly out of this vertex form. And since we know the axis of symmetry is going to cut the parabola at the vertex, it's going to intersect right there in the middle, we know that that middle point is H. So again, just by looking at the vertex form equation, I can look at the number for H and the K and be able to tell you the vertex and the axis of symmetry. I don't need to graph it. I can just look at the equation and go for it. Now, if it is more helpful for you in this lesson to continue to graph the functions to be able to talk about the transformations, that is totally cool. Keep doing that. Keep rocking it out. But we should start trying to be able to look at equations and without graphing it, be able to tell you exactly what happened. So like on number 1, we're comparing this function to the parent function. Now we always typed this in and graphed this first when we were graphing our transformations because we wanted to see how our transformation compared to it. And we can still do that, but we can also compare the functions. Compared to x squared, this equation has a number in the front and has a number added or subtracted on the inside. Those line up exactly to one of the letters from Vertex Form. That means that A is 3. And that means that H is going to be -4, the opposite of what you see, because horizontal is inside and opposite. Now since A is 3, that's a Dolly Parton number. That means this is going to be a vertical stretch by that factor of 3. It should get narrower. And because H is -4, I know that's a horizontal translation to the left 4 units. Now I can totally check that with Desmos, and we're going to do that just now. Here's my Desmos, and I'm going to play this video. If I turn on the b of x function, you can immediately tell it moved to the left and it's narrower. Though if you can't tell that it's narrower, take away the translation and see that it's actually narrower than the parent function, and then move it back so you can guarantee you got that right. Very, very cool. All right. So we know that we got this right, that it is a horizontal translation to the left 4 units and a vertical stretch getting narrower by a factor of 3. Now I'm not going to graph anymore for the notes just to save time, but feel free to always do that for yourself when it comes to the graph. Okay, let's look at number 2. I'll point at the things that are different when comparing this function to the parent function. There's a negative sign in the front. We're subtracting a number on the inside, and we're adding a number on the outside. That means that there are 3 transformations performed on the parent function. One of them is a reflection in the x-axis. That will make this a sad parabola. And since we're subtracting a number on the end, that's a vertical translation down 9 units. And since we're subtracting a number on the inside, that number we're subtracting is 1, so we're moving to the right 1 unit. Because A would be equal to -1, H is going to be equal to 1, and K is going to be equal to -9. Those are all the numbers that I've substituted into Vertex Form to create these transformations. Let's check out number 3. How many things are different? How many transformations have I applied to the k of x function? 2, very good. Yeah, there are 2 changes to this equation, which means there are 2 transformations. Essentially, there are 2 numbers as other than x squared, that are in this equation. Now, this 1/8 in the front, what type of transformation does that mean? Yeah, you know you're multiplying that number in the front, so it's a vertical transformation, and it is a vertical shrink because that's a JLO number. So my A is 1/8. That's JLO. That means it's going to be a shrink by a factor of 1/8. It's getting wider. And since H is the number 6, which direction am I horizontally translating this? Yeah, I'm translating it to the right 6 units because it's a positive H value, which means it looks like it's negative in the equation, the opposite. Very cool. You guys are going to try number 4 on your own all the way through. Can you tell me what transformations have been applied to the m of x function? How'd you do? This one is a vertical translation up 10 units because k is 10, and a horizontal translation to the left because h is -7. Plus sign in the inside, minus sign when you take it out. Cool, now we're just not going to spend forever looking at these graphs and talking about the transformations. We're also going to be writing equations in Vertex Form using transformations. So every time we start, we're going to start with the parent function and then apply the transformations in the little word problem here to create a new g of x function. Okay, if we read along with this question, it says that we are going to do a reflection across the x-axis, then a translation up 4 units, and to the right 5 units. So I need to make sure that A is negative, because that's how I make a reflection, that K is 4, because that's how I move it up, and that H is 5, which means I'm plugging in a positive 5. All right, here's g of x. G of x is going to be equal to, all right, that negative A. And I need to plug in an h of 5, which means we're going to subtract 5, because the subtraction sign is already in the formula. Remember, positive on the outside, negative on the inside. And then we're going to go up 4. That means I'm going to add 4 at the end. And voila, I've created a vertex form function that does those things. If I wanted to check and make sure that visually it actually does reflect across the x-axis, move up and to the right, you just type g of x into Desmos and see that it actually does that. This is a very visual concept. I want you to pause the video and try number 6. You're going to get questions like this, but I think we can handle it. All right, how'd you do? Remember, our vertical stretches are multiplied in the front of the equation. Our translations up and down are added or subtracted at the end of the equation, and lefts and rights go inside the opposite direction. So even though left is normally to the left, to the negatives, we're going to have plus 2 because we'd be plugging in a negative 2, and minus a minus is positive. We'll get more practice with that in class, don't you worry. Now the last little bit is super duper fun. Okay, again, when we did this a second ago to find the vertex and axis of symmetry from standard form, we needed to graph it, we needed to use Desmos to tell us the important points, and then remember what the vocabulary word is. But with vertex form, we are very easily able to talk about the vertex and the axis of symmetry, because this is H and this is K. And the vertex is always the coordinate h comma k, so like, okay, 3 comma 7, that's the vertex. Because the 3 is the h and the 7 is the k. And then I also know that the axis of symmetry is going to be x equal to 3, because these numbers should always be the same. The axis of symmetry and the vertex have the same x value. So I'm going to let you try all of these. Really, you don't need any more information than that. Please write the vertex and axis of symmetry for number 8, 9, and 10. You got this. All right, now I didn't finish number 10 because I want to point this out to you. Some of you might have paused here and been like, okay, Miss Quigley, there is not a number back there, so I don't know what K is. But remember, when there's not numbers showing, you have to remember what your invisible numbers are. If there's nothing back there, it's like we're adding 0. So my y-coordinate is 0. Yet again, this is a very visual concept, so if looking at the equations to find the vertex and axis of symmetry is just not working for you, you go ahead and you graph each and every one of these functions. You would be able to see on Desmos where the vertex and the axis of symmetry is, and voila, you have your answer. Use your resources to help you. All right, we'll keep practicing vertex form in class. See you guys soon.